We're now going to approach some problems which use, and in fact, not only do they use radian measure, they require radian measure. If you do these problems, measuring the angles in degrees, the results you get are not correct. And so we're going to take a look at some of these problems, and some of these problems are the kinds of things that you would encounter in a physics course, in a mechanics course, and so these are pretty standard, pretty basic, ordinary kinds of problems. Some of them are a little bit less, a little more esoteric, but all these problems are practiced using radian measure. Now, there are a couple basic principles we want to have. The first we've mentioned before is the relationship 180 degrees. Again, I'm using equals. I shouldn't use this here, but I'm just saying 180 degrees corresponds to. I'm using 180 degrees. This symbol now means corresponds to pi radians. And the reason I'm using this equal symbol is because I can do this. Suppose I have an angle. Suppose we're given an angle, and it can be any measure we want. I want an angle measuring 74 degrees. The question is, what does that measure in radians? What is 74 degrees measured in radians? Well, all we need to do is set up a proportion. 180 is to 74 as pi is to don't know yet. 180 is to 74 as pi is to don't know yet. Now, in the computation, you do not need to write the degree symbol. This is just computation. But when you write your final result, anytime you have your result in degrees, it does need to have the degree symbol. Our answer is going to be in radians. And so all we need to do here is cross multiply. So for any given angle in degrees, set up this proportion. 180 corresponds to pi, 74 corresponds to don't know yet. 180 is to 74 as pi is to x. Cross multiply this way. 180x is equal to 74 times pi. Solve for x, divide both sides by 180. 74 pi over 180. And then, and only then, do we reach for the calculator. Show this work, that way I know that you know what you're doing. Now we reach for the calculator. And all we need to do is 74 times. Now, here's the next piece. On your scientific calculator, you have a button which gives you pi. Do not, for this course, simply use 3.14. Do not use 3.14. That's not the value of pi. It's an approximation. It's not the value of pi. On your machine, you have a button which gives you pi, and the decimal string is exact. So find that however you need to use on your machine. There's this new thing called the internet. So if you don't know how to make your machine give you pi, then you need to go on the internet and say, how do I make pi happen on my Casio, whatever number Casio calculator you have? In my particular case, I do second button and up, and there's my 74 times pi. And then divide by 180. And my value is, I have 1.29154, yada, yada, yada. And let's say for our work, suppose for this problem, suppose we want 2 decimals. So we're going to round to 2 decimal places. So we would round, and we would use, and when I write equals here, I mean equals by rounding. This is not technically equals, but I'm redefining this symbol. This means equals by rounding. Some people would require that you write approximately equal. I'll be a little more forgiving for now. We have bigger fish to fry than that. So I will allow you to say equals 1.29 because this means equal by rounding. This is radians. If you wish, you may put RAD. You do not need radians. If you do not put a symbol, then I will assume you mean radians. That's how you translate 74 degrees to radians. If you had any other angle, suppose, here, let's try this, given. Here, you do this. Given an angle of, let's say Suppose angle, let's do this. Let's use a new symbol here. I'm going to use the Greek letter alpha. Suppose alpha is measured at 16.7 degrees. Convert, give me 2 decimals. So round to 2 decimals, convert to radians. So pause the video if you like and go see if you can do that. And then when you come back in, I'll see if I can match the work that you've done. So go ahead and pause and do your work now if you like. All right, so I hope you've done almost, essentially it's exactly the same computation. We're using 16.7 in place of 74. So the process is the same. Essentially 180 is to 16.7. Remember, in the computations, you do not need the symbol for degrees. 180 is to 16.7 as pi is to don't know yet. If you like, you can write this as theta. We're finding theta if you like. And so cross multiply, set them equal. 180 times theta is equal to 16.7 times pi. Divide both sides by 180. Then and only then do you reach for the calculator. And I'm going to clear. I'm going to say 16.7 times pi. I'm going to divide that by, what's my number? 180. And my value is 0.2914. And I'm going, so this is 0.291469, yada, yada, yada. And I'm going to approximate that to be 0.29 radians is my final result. So converting from degrees to radians and radians back to degrees should be very straightforward here. And so now what we'll do is, if you've practiced that a few times, in the next video we'll actually take up the actual problems that require working with radian measure.